discuss on internal table and work area. What is internal table and what is work area? So we'll discuss that. So let me do one thing before starting. So let me copy an image. Let's copy this. So this is our 3-tier architecture, right? Just remove these things. Right, so this is our application layer, this is our database layer where all the data will be stored, right? So database layer, this is our database layer. So this is the presentation layer. So now if we want to store the data, so the data will be stored in where? In the database layer, right? It will be stored in database layer. So this is where the data will be stored, in the database layer, in the tables. Remember tables? Table stores data physically, right? Let's say Mara table, right? So here our data will be stored one by one. Records will be stored in the database layer. So let's say these are our records. These are the records, those are stored in database layer. Okay, in table, these are the records, those are stored in table in database layer. So if we bring this data, these records, if we bring it to application layer, we need some memory here, right? We need a memory to store the data. If you are bringing multiple records, all the records or some few records, if you are bringing from the database to your application layer, then you need memory in application layer to store or not. Memory is required or we don't need memory to store the data. If you are bringing to application layer, we need memory or not?
Yes, sir.
We need memory, right? So the same memory will be allocated using internal table. Okay, the same memory will allocate using internal table. The internal table itself and memory that will be allocated to store multiple record at a time in runtime in the application layer. Clear? Or any doubts? What is internal table? Is it clear? Clear about internal table?
Yes, sir.
Okay, so this is what internal table is all about. So let's write it now. Internal table. Okay, internal table. So internal table is a memory allocated at runtime to store internal table. Internal table is a memory allocated at runtime to store multiple records at a time. Okay, multiple records at a time, that is internal table. Very simple. Internal table is a memory allocated at runtime to store multiple records, right? So internal table is a memory allocated at runtime to store multiple record. Remember this, allocated at runtime only. Okay, once the program got executed, there will be no data. Okay, there will be no data in internal table, and the memory also will be vanished. Okay, it won't be exist in application layer. Okay, this memory will be created in application layer. Okay, application layer to store multiple record at a time. There are three types of internal table. So one is standard internal table. So second one, sorted internal table. Third one, hashed internal table. Okay, there are three types of internal tables. Let's discuss one by one. Okay, we'll discuss one by one. So okay, standard internal table. So one by one we'll go through and we'll see. Okay, standard internal table. So standard internal table will support, it will support row index. Okay, standard internal table will support row index. What is that row index? So we'll see in the system. Actually, whenever we perform read statement on internal table, we can use index 1, index 2, like that. Okay, let's see first internal table and then we'll discuss the properties. How internal table will look like, we'll see. So this is the program. So program batch 6 that we are using. So we'll see inside this, we'll create a structure and then we'll create an internal table. Okay, structure is mandatory for internal table with the whole syntax. There is a whole syntax, then structure, we have to refer to structure if you want to create. So let's comment all the code. So let's create and structure first. So we have seen what is structure in previous classes. I don't think it's again required to explain the things. So I'll do one thing, I'll use a pattern, okay, to generate a structure to make my job faster. I'll use a pattern, let's say Mara. So I'll select matnr and mtrt, these fields I'll select. Okay, so then what I do, I click on copy so that the structure will be copied. So I use ty means structure. So I don't want to allocate the memory for this mar underscore ty. I just want to use it as a structure, so I use types keyword. Okay, so if I use types keyword, there will be no memory allocated, we have seen in previous class. So now we'll declare an internal table. So how to declare an internal table? It's very simple. So if you want to allocate memory, then use data keyword that we know already. So data, and then let's say internal table name it underscore mara. So this name can be anything. Okay, you can provide any name, it's not constants. Like you have to provide this name only the thing that you are seeing in a blue color you have to worry about. So other thing you can provide any name. Okay, so structure. So let's say type, you need an internal table, table of, specify table of, you need an internal table, specify table of, and then use your structure here. Okay, use your structure, simple. So based on this structure, so your internal table will get created. Okay, so let's write some select query, select. So to speed up the process, shift alt and arrows, copy paste here, and then from which table you want to take, from the target, sorry, from the source is mara, where you are going to store in the application layer in the internal table. We'll discuss more on select queries, nothing to worry about as of now, just understand. Okay, the select queries are used to bring the data from the database table to your application layer. Okay, that's what the select queries will do. So selected columns. Okay, so it underscore mara. So let's say I say up to 10 rows. Okay, 10 rows. So this is what I want to say. So this is an let's say 100 rows. Okay, let's say 100 rows. So we can also say around 2000 rows, no problem. Check for error again. So activate the program. Okay, let's keep breakpoint and let's see in the runtime how the how internal table will look like. Execute it, and then you can see when you double click here. So this internal table is created. See here. Okay, this is the internal table with the same structure, right? The structure that we have defined. Structure is a skeleton. Structure is a skeleton for your internal table or work area. Okay, that's what structure do. It defines a skeleton of internal table or work area, but structure will never store the data. It will just act like skeleton for your internal table and work area. That's why we need structure. If we don't have skeleton, then our internal table will not look properly, right? So if we don't have skeleton, then what will happen? We look like amoeba otherwise. So to define that structure for internal table, how the internal table should look like, we create an in structure. Okay. So see now, MATNR, MTIRT, MBRSH, and MATKL. All the technical properties are copied. All the technical properties are copied into each field of the internal table. All these technical properties, right? So what is technical properties? What is domain? Who remembers what is domain? What is domain?
It provides the
Technical properties.
technical properties and semantic attributes, I think, to the data element.
Yes, okay, you're right. So technical properties means
Data type plus the length.
very good answer. So see data type and the length, right? So let's bring some record from the database. Okay, so now there are no records in the internal table. So all the records are there in the database as of now. What we are doing by writing a select query, we are bringing the data into our application layer. See now. So I'll go back here, I'll go back, I press F5 from my keyboard. So then this code will get executed. So you can see 2000 records are coming from the database and it is getting stored in our application layer. You can see here, see all the records are coming and getting stored in our application layer. This is the internal table. To store the data, we use internal table. Okay, to store the data, we use internal table in application layer. This data will only store at runtime. It's not a physical memory that has been allocated. It's a temporary memory. Okay, temporary memory in application layer. Okay, we can call it as flash memory. It will not last for longer time. Okay, it's kind of flash memory. So see, all the records are coming. Okay, so what I was saying, for this standard internal table, this and standard internal table, this is one way to declare a standard internal table. The other way is I say control D, so above line will be copied. So the other way is to declare standard internal table. Is both are same, there is no difference. Maybe you can observe in the debugger also. See, let me show you that. Okay, I'll just comment on line. So activate it. Okay, one more time I'll just execute so that I can show you this and standard internal table. Okay, let's press F8. See here, when I double click, it's saying standard table. Okay, this is an standard internal table. Okay, and also if you want to see the memory, okay, if you want to see the memory of the internal table, it's very simple. It's very simple. Go to memory analysis tab. Okay, so and then go to your variable. This is your data object or variable, right? Double click here. See, as of now there is no memory allocated, 0 it is showing. So after execution of this statement, just observe, it's allocating some memory as per the records that we are bringing. Okay, so as per the records that we are bringing, it is getting allocated, memory is getting allocated. So around 1,31,600 bytes is getting allocated. Okay, that's what happening at the runtime. Okay, so now we understood this is one way to declare the internal table. The other way is there's no difference in both internal table, both are same. We can use standard table of to declare standard internal table, no difference. No difference between both. Okay, so just execute it. Press F8. See now, it underscore Mara, it's a standard table. Okay, this is the other syntax that you can use to declare internal table. Okay, to declare internal table. So now what I was saying, so I was saying here it will support row index. Okay, I was saying it will support row index. What is that row index? Actually, whenever we perform read operation or loop, okay, so read table, okay, read table is to read the data from internal table to work area. We'll see more on these things when I start with the regular class. Okay, so not regular class, sorry. So when I start with internal table operation, see, so you can perform this kind of index operation. Okay, you can perform this kind of index operation on standard internal table. That's what I was saying. Okay, we'll see this in future classes. We'll see maybe tomorrow or today itself. If it's possible, I'll show you today itself. I'm not sure whether it's possible or not. If possible, I'll show you today what is this read table. Okay, so you can perform this kind of index operation or delete index or insert with index or delete with index, modify with index. That kind of index operation can be performed on this standard internal table. Okay, that's what I mean to say. It will support row index. Okay, so you can perform index operation on this. Okay, next one. Okay, you can access record using key, field, or row index. Okay, same thing above one. You can, if you want to read the data, you can also read the data based on, maybe it would have been better if oh, it's okay, let it be separate point. So you can access the record using key field or row index. Okay, you can access the records of this internal table using key fields or row index. Okay, so what is key field? So how can we access using records using key fields? It's very simple. So same it underscore Mara. Okay, so transporting no fields. Let's see with key. Okay, with key, let's say matn are equal to some material number, so m-10, something like this. Okay, this is a key. Okay, you can access the record using with key or or index like this. Okay, or index like this. It support both a key and index. Okay, so maybe it would have been better if I show you the what is this read statement will do. Yes, please. Yeah, yeah.
So,
Yes.
like, why do we need table structure and the structure and tables? Because when we run the tables and all in the presentation layer, okay.
Sorry.
When we run this, tables in the
Hmm?
presentation layer
Hmm?
for Mara or
Those
anything, it would
Mara
be.
tables are not in the presentation layer. Presentation layer is only for display purpose. Actually, the object of those Mara table will be created in the database itself, here itself. We have seen, right, the SQL trace st05 we have done while creating table. You have seen the SQL create statement is sending to database to create the table. You have seen, right? So in application layer, only runtime object will be created. If you go to S11 and if you see Mara table, okay, Mara table, there will be no physical memory for the Mara in application layer. Only the runtime object will get created in the application layer. You can see runtime object. Go here and display. This is a runtime object. Okay, so one runtime object will get created in the application layer. Okay, so and also this table as created in the database physically to store the data. Okay, this data will not be stored in application layer, never and ever. Okay, or if it is not buffered, I'm talking. If it is buffer table, then it definitely it will store. If you go to display object, see here, this is the table that got created in the database layer, right? So what we have to do, if you are bringing the data from the database layer to application layer, we need some memory, right? We need some memory in the application layer. That's why we are creating that memory using internal table. Clear?
And from application to presentation?
It's not required. This presentation layer is just to display. Okay, it will use this application memory itself. It is only for display purpose, no use.
Then it display in the
Sorry?
presentation layer.
Hello?
Whatever is there in the application layer, it will just display in the presentation layer.
Yes,
That's it,
that's
right?
all. That's all. Yes, that's it. Understood?
Yeah.
Okay, so okay, let's proceed further where I was. So I was discussing about this read statement, right? So let me show you one more thing. Work area first we'll see. So work area, what is work area? So you cannot directly operate on internal table. Okay, you cannot directly operate on internal tables. You have to create. And one more thing I want to say, internal table is not only created when you are bringing data from the database to application layer, and also if you want to copy this data to another internal table or something like that, then also we can create the internal table. Okay, and something like that. Okay, there are many operations that we can do on the internal table. We'll see in tomorrow or today's class itself. Okay, we can also create internal table, and also we can no need to bring data from the database layer, and we can store the data here itself. We can fill internal table in the application layer itself. Okay, that is also possible. In that case also we need an internal table to perform operations. Okay, so one more thing now, for I'm discussing on work area. Okay, so work area is used to store single record at runtime. Okay, so if you're bringing single record from your database layer to your application layer, okay, your database layer to your application layer, or else you're reading the data that is exist in the internal table, and you want to store and you want to perform some operation on the record, okay, on particular record, then what you need, you need an work area, because you cannot perform operations directly on the internal table, or else you cannot display the data that exists in the internal table directly to the output. What you have to do, you have to bring one by one record into your work area, and then you can display. Or else if you want to perform some operation on the record, you have to bring that record into your work area, and then you have to perform the operation, and then again you have to modify this internal table, or else you can store that data in some other internal table. To do these things we need an work area. So what is work area, we'll see now. Okay, so work area, it's very important now. So work area, so work area can store single record at runtime. Okay, single record at runtime, that is what work area is. Okay, work area is a memory. Work area is a memory, let's say memory allocated at runtime. Okay, runtime, allocated at runtime to store single record. Okay, that is what work area is all about. Only it stores single record, it cannot store multiple records. Okay, so how can we declare work area? It's very simple. Just say provide some user defined name for your work area. User means us, we are the users. We can provide any name that we want to. Okay, this is an user defined, and then your structure name. Okay, and your structure name. This is how you can declare the work area. This is how you can declare and work area. So now, so if you want to read the record, okay, if you want to read the record from internal table to work area, then you can use read or loop statement. Okay, we'll see first read, and then we'll see later classes. I'll show you definitely what is loop statement. You'll see that it's very important. Okay, let's say I'm not sure whether this material is there or not. So if material is there, if sy if and su brc equal to 0, so let's say break. Okay, so let's do pretty printer, check for error and activate. Why sub rc? It's a system field. Okay, I have not discussed it, so we'll see that in the future. If this statement is successful, then it will go inside the code. Okay, that's what this read statement will talk about, this if condition. Okay, let's see now. I'm not sure whether that material is there or not. So if material is there, then size sub rc value will be 0, or then only it will go inside, or else it will not go. Okay, let's press F5. Size abc 4 means there is no record inside this internal table. See now, maybe we can also search with the same record material number that I'm searching, putting here. So see here, we'll go inside this m-4000 display. Click on this icon, okay, or else just press a Control F. It will open and pop up. You provide here, okay, provide the material number here and search. See, it is saying no hits found. Okay, so what we do, we have entered wrong material number. I have to enter this MSA-100. So instead of that, I have entered 10 only, so it's not accepting anyhow. So let me show you by reading that material. Okay, so what this work area will do. Okay, let's understand work area first and then we'll go forward. Execute it. Okay, see now, internal table and work area. Okay, internal table can store multiple record, work area can store single record. Okay, only single record at a time. So see now, I press F5 now. See, size above is 0 means this statement is successful, means there is a record inside internal table. Okay, this material is there inside internal table. If you go to work area, so the data is read to and work area. Okay, so this is an work area. Okay, this is an work area. See, I was saying here, so you can access record using key field or row index, right? You can access record using key field or row index. See here, either you can access record using index like this, or else you can access the record using like this with key. Okay, so standard internal table supports both using key field or using row index. Okay, that's the next. Okay, that's what I was saying. So next point. Okay, so let's see one more thing. Let's execute this program. So with non-unique key. Okay, see, this internal table, standard internal table supports non-unique keys. Okay, non-unique key. Okay, let's say Magner. Okay, standard internal table supports non-unique key. Okay, non-unique key means what? What is non-unique key? What is the difference between unique key and non-unique key? Who will answer?
Other than a primary key, it's called a non-unique key.
Okay, so what is the purpose of unique key? What is the meaning of unique?
It will never allow the duplicate entries.
Wow, very nice answer. Unique keys will never allow duplicate entries, but non-unique keys will allow duplicate entries, right? So it will.
Yes.
Very good answer. It will support only the non-unique key. Okay, it will only support non-unique secondary keys. These are secondary keys. Okay, secondary keys. Okay, let's see in the system whether it's a secondary or primary. How can we see that? So we can see in the debugger. Whatever happens, we can always observe in the debugger to understand the things better. Let's see. I think it's a primary key or secondary key. We'll see. IT_Mara. So now if there are no records, then it will not show any key field. Okay, see here, standard primary key, it is saying non-unique. Okay, see, saying non-unique. Yeah, good. So anyhow, it's a primary key, not secondary key. We can also declare secondary keys for, see here, primary key, and it is a non-unique key. Okay, primary key and it is a non-unique key. Okay, so standard internal table supports non-unique keys. Non-unique keys means it can store duplicate records. Okay, we can also create secondary indexes, secondary keys. Okay, so how can we create? We'll see that in the future. Okay, maybe now it is little bit difficult. Okay, I'll show you in the future. Okay, maybe I'll show you in today's class also. I can show you. We'll see that. Okay, understood this point? It will support only non-unique key. Okay, it will support non-unique key. It will not support unique keys. If you say unique here, it will throw an error. See, it's throwing an error, red color. If I check, it will show you a beautiful error message. You can only use unique with table type as the table or sorted table. We cannot use unique key with standard internal table. That's what system is saying. Line number 273. That's the beauty of SAP system. See, line number 273, it is, there is an error. It is saying you cannot use unique for standard internal table. That's what it is saying. Okay, so it support only non-unique key. Okay, this is one point. So next point, so it supports linear by default. Okay, let's say by default it will be better. By default it supports linear search. Okay, by default it support linear search. Okay, by default it supports linear search. What is linear search? What is binary search? Maybe we'll discuss that now, and later we'll see. Anyhow, we'll complete internal table operations today. Sorry, internal table types of internal table. Tomorrow onwards we'll start internal table operation. Okay, so first we'll understand what is linear search and what is binary search. First we'll understand what is linear search. Okay, let's take an example of records. Okay, so this is your records. Okay, this is your records. I'm talking about here. Okay, so let's say you have a record called material number 1 2 3 4 5 6 6 7 8 9, okay, 10 11 12, something like this. Okay, some random material numbers or something, some records 13 14 15, okay, something like this. Okay, something like this. Now what is linear search? What is linear search? That's what we have to understand. Okay, so okay, linear search access or search record sequentially. Okay, linear search records in internal table sequentially. Okay, let's understand what is sequentially. Okay, so let's say you're saying read table. Okay, read a table. Okay, so it underscore Mara, let's say this is a Mara internal table. Okay, so into work area underscore Mara. Okay, work area underscore Mara with key matnr equal to, so let's say you're searching for record 8. Okay, you're searching for record where material number equal to 8. What will happen internally when you perform this kind of select queries, this kind of read statement? So let's discuss, let's understand that. Okay, so first how this will search the record inside the internal table. So what we'll do, first it will go and search the first record. Okay, so it will read the first record and it will check whether it is matching for our record or not. First thing, it will search for the first record. Okay, so here this is not the record that we are looking for. We are looking for 8, so this is not matching, so it will go to second record. This is also not matching. It will search for the third record. It is also not matching. It will go for the fifth record. It is also not matching. It will go for the sixth record. It is also not matching. So next record is sixth record, then 7th, and then 8th record. Now it is matching. So now it is matching. The record is there at the position 8. The record is there at the position 8. So then what it will do? It will bring this record into and work area. It will put this record inside and work area. It will bring and it will put the record inside work area. This is how the linear search will work. It's a sequential search. Record by record it will start searching. Okay, that's how the sequential search will work. Linear search. Okay, that is a linear search, means sequential search. Is it clear? Linear search.
Yes, sir.
Okay. Okay, next one is binary search. Okay, next one is binary search. Let's take the same internal table. Okay, for binary search, sort statement is mandatory. Okay. It will divide. See, binary. Okay, bind means what? Divide into multiple times. Okay, always it will divide. Okay, binary means 2, right? So you can understand like this. Okay, it will divide the the table, divide records of table into always it divides. Okay, let's say always it divides, always it will divide the records of the table into multiple that here. So I'll tell you how it will work. Okay, so let's change the sentence. It will search. Okay, first thing you have to remember, the record should be in sorted order. Okay, it's mandatory. Search records by dividing into of repeatedly, right? Repeatedly. Okay, it will search the records in the internal table by dividing into of repeatedly. All the times it will start dividing the records repeatedly, and it will search the record, and also it will compare with target value, right? Target value, it will compare it into target value. Let's understand. Okay, and mandatory thing. So mandatory thing is what is mandatory thing for binary search? Sort statement. Okay, internal table should be, must and should be sorted, in ascending order. It should be must and should be sorted in ascending order. Okay, ascending order. That's the condition. That's a mandatory thing that you have to remember when you're performing binary search. Okay, let's understand now how this binary search will work. Okay, this is linear search, right? Linear search. This one is binary search. Okay, binary search. Binary search is always faster than linear search. Okay, so it doesn't matter the records, number of records that is exist in the internal table. Some people say that if less than 100 entries, then use binary search. It doesn't matter, it's always faster. Okay, don't worry about how many records you have. I've tried it in system, so it always faster. How many 5 records, 2 record, 1 record, it will not worry. Okay, let's understand. Okay, let's come back, let's understand what is binary search. So what it will do, okay, what this binary search will do. So there are 15 records. Okay, what it will do, we are searching for which record? We are searching for record 8, right? So what it will do, there are 15 records. First it will divide into internal table into off. Okay, so first thing the binary search will do, it will divide the internal table into off. It will divide the internal table into off. Okay, that's what the first thing it will do. Okay, so very simple. Next thing it is going to do, it will just compare this target value with the previous value. Okay, whether it's less than or greater than. Okay, so if the target value is greater than this value, okay, if the target value is greater than this value, okay, if target value is greater than this last value, so then it will ignore this part. Okay, it will ignore this part. So next what we'll do, this part, the below part, again what system will do, it will divide into 2 parts again. Okay, so 2 parts, let's say 8, 9, 10. So let's say it will divide into two parts. Okay, so again it is dividing into two parts now. Okay, so now it will compare this target value with this last value of this above part. Okay, so okay, what is happening here is that this 11 is greater than 8, right? So then what will do, it will ignore this part, and what it will ignore this part. Okay, it will ignore the below part, and again what system will do, system will divide the above part into again two places. Okay, so again above into two off. Okay, it is again, it will divide, so again it will compare this 8 with 9. Okay, 8 with 9, 9 is again greater than 8. So again what system will do, okay, what system will do, so again it will divide this into multiple, again off. So again it will compare with the previous value, this 8 is matching with this 8, both are same, then this record it will bring it into work area. This record will bring it into work area. This is how binary search will work. Any doubts, about binary search? Any doubts?
No, Raj.
Understood?
Once
Clear?
again, but
Once
Yeah.
again you want to understand binary search? Okay, so
yeah,
okay, so let's, do you want me to delete these things and rewrite again, or is it okay if I just explain?
no, it's okay, it's okay, it's okay. Just
Okay,
explain.
so what binary search will do, it will divide this complete internal table records into two offs. Okay, two offs. So it will compare the previous value with the target value. Okay, so if target value is less than the previous value, then what it will do, it will search in the next off. If it is greater than the previous value, it will search in the first off. If it is less than the previous value, it will search in second off. Okay, again it will not search in second off, again it will divide this second off into two parts. Okay, again it will divide the second parts into two parts. Again it will check the previous value is less than the target value or not. Okay, okay, it will check whether the previous value is less than the target value or not. So in this case the target value is less than this previous value, so it will ignore the below part. Okay, second off, so it will search in the first off. Okay, so it will again, it will not search here, it will divide it into two parts again like this. Okay, so it will compare the previous value. So again this previous value is greater than the target value, so it will search in the first off instead of in the second off. Again this thing will be divided into multiple, and what it will do, it will divide, it will search again the previous value is matching with the target value or not. In this time, in this case, our previous value, this value is matching with our target value, so it will bring the records into our work area. That's how the binary search will work. Clear, Santosh?
Clear, clear. Yeah.
Okay, so very good. Can we proceed
Raj,
further? Yes.
Raj, in this one, like you are saying that it will be dividing the table into two halves. So
Yes.
the first half it is not matching, means again in the second half it will again divide it into further two, is it?
Yes, further two, further two. See, off into dividing, it will search the record by dividing into off. Repeatedly, it will keep dividing. This word is very important. This word I was not getting. Okay, so
Until it
repeatedly,
reaches the target, it will keep on dividing the data.
yes, until it's reached the target, it keep on dividing the data. So in this case, if you are not sorted the data in ascending order, what will happen? You might not get the right record. Okay, so you will not get the right record. Sometimes you may get it. Okay, sometimes you will not get it. That's what happen. Always remember to sort the internal table in ascending order. Why? Because it always keep compare the previous value of first off. Understood?
So here in the second half, they will, it will get divided like 8, 9, 10, 11, and then 12, 14, and 15, right?
Yes, correct. 8, 9, 10. First it will compare this value, okay, and this, okay, it will divide again. This is second off, this is first off. Okay, again this one, it is not matching with this one, so again this value will be divided into two offs. Okay, so again it is not matching here, it is again, this value will get divided into 2 offs. So you got the final record, bring it into your work area. Clear?
Yes.
Okay, so let's proceed further. Okay, so here you understood what is linear search. Okay, by default, standard internal table supports linear search. Okay, you can also perform binary search on the standard table by explicitly you can specify binary search. You can sort the internal table and you can say binary search. Okay, binary search, and then you can search the record. Okay, by default, if you don't specify anything, by default it supports linear search. Okay, linear search. Okay, so that's what linear search here. Okay, so here key field in the standard internal table, key field is not mandatory. It's not mandatory. Key field is not mandatory. You can see in the system, I think I lost the connection. Let me re-log in. So this was a program that we were changing, we were creating to understand the basic programming thing. So let's go inside this, understand the concepts. That is very important as of now. Okay, in future I'll tell you how can we use the things. Okay, see here, you can declare or you can ignore the key field. System will not throw any error. Okay, key field is not mandatory. Okay, key field is not mandatory for a standard internal table. Okay, you can declare or either you can leave it. Okay, that's what standard internal table. Okay, key fields are not mandatory for standard internal tables. Okay, you can sort the row can be, means let's say internal table, or else let's say row can be sorted explicitly. Okay, row can be sorted explicitly. You can sort the row explicitly. You can perform sort operation on this table. Let's say sort, we'll say sort, nothing to worry as of now. Sort internal table by some field. Okay, see, you can perform the sort statement on standard internal table explicitly. You can do the sort statement. Okay, so but in other internal table, this for sorted internal table, it's not possible. These are the things that you have to remember. Okay, these are the things you have to remember whenever I say standard internal table. Okay, whenever I say standard internal table. Any doubts in the standard internal table, or is it clear? Can we proceed? Can we proceed further?
Raj, I have one doubt.
Yes.
So when to use non-unique key in a standard internal table?
Non-unique key, it's not at all required. Okay, so it's
Required.
not at all
Okay.
required. Okay, because anyhow its key field is not mandatory, right? So if you want to use, you can use it, or else you can leave, ignore. It's not required, not mandatory. Okay,
Okay.
not mandatory. So see here, anyhow it's based on MATNR, you can use it. Let's say for example Mara. Mara is a unique record, right? Based on MATNR. So if you go to MARC, it's not against MARA table, it's not unique key, right? Unique data, right? So it's a non-unique based on MATNR. So in that case, you can say non-unique. But here in Matner, this Matner is a unique field here, right? So you have to use unique. Anyhow, it doesn't support unique keys. Standard internal table doesn't support unique keys. You can ignore. Okay, this is how you can declare the standard internal table. Clear, Salman?
Yeah.
As in this standard, in this like internal table, like we don't have to define any keys, right? Because we will be declaring a structure, and from
Yes.
structure we would have defined, right, which is a primary
No,
key, and
we cannot declare the key fields in structure. It's not possible. Okay, let me go back to S11. Is it possible in S11 you have created structure in S11, right? We have created some structure in S11. Did you create any? Okay, this is not the structure that we created. What is structure that we created? Okay, let's say Mara underscore TY, I guess. So see, is it anything is there to specify key field in the structure here? Any column you're seeing key field? No, right?
no.
So if you go to table, there's a column here, key field, right? See, that's what, for structure there are no key fields. You cannot define the key fields for the structure. It's not possible. You have to declare, while declaring we have to specify the key fields when you're declaring internal table, not while declaring structure. Okay, clear, Deepak?
Okay. Yeah.
Okay, so next one, sorted internal table. Since you understood standard internal table, it's very easy to understand now sorted internal table. Okay, so let's discuss the points on sorted internal table and let's come back to program. Okay, first we'll discuss the points. What are the things that you have to remember when I say sorted internal table? Okay, so let's say, so okay, it will also have the row index. It will, okay, so we'll make it as one field. Okay, okay, let's copy the same point here. Key, you can access the record using key field or row index. Okay, so here what is this? It will support only unique, non-unique key field, right? So it supports unique, and non-unique. Okay, sorted internal table supports both unique and non-unique. So here by default it's a linear search, right? So here by default it's binary search. Okay, by default it is a binary search. You know what is binary search now, right? So here key fields are not mandatory. Here key fields are mandatory. Key fields are mandatory. Okay, here key fields are, okay, I'm writing again, it's not required. Now, key fields are mandatory for sorted internal table. Okay, here you can sort the row, sort the internal table explicitly. Here you cannot sort. Okay, here in this case rows are always sorted by key fields in ascending order by default. Okay, so in this rows are always sorted by key field in ascending order by default, and then no manual sort statement is allowed in sorted internal table, and then no manual statement is allowed. No manual sort operation is allowed. Okay, means it will not allow the sort operation here. You cannot perform sort operation on sorted internal table. Okay, these are the points that you have to remember when I say sorted internal table. Okay, let's see in the system. Clear about these points? Any doubts here? You know, right, what is index access and what is row key field access? This is index access. Okay, you can specify index and then you can get the records. Okay, this is key access. You can specify the key fields and you can get the access. You know what is binary search also now? Everything you know now. Okay, all the things we have discussed. Only thing is we have to see in the system. Any doubts in this points in sorted internal table?
Alright.
Okay, so okay, let's see how can we declare sorted internal table. It's very simple. It's very simple. Let's say data it underscore Mara, type sorted. Instead of standard you have to say sorted table of your structure. What I said, key fields are mandatory, whether it's unique or non-unique it doesn't matter, but key fields are mandatory. See, when I check, if I don't define any key field it will throw me an error. The key specific is incomplete, line number 278. That's the beauty of SAP. Line number 278, you are missing the key fields. That's what system is saying. So let's define the key field. Okay, I said with unique key matnr. Okay, with unique key matnr. Okay, with unique key matnr. See why what is it is saying it underscore mara is a table kind of sorted. You cannot use sort command with this type of table, so that's what I have written here. Rows are always sorted by the key field in ascending order by default. No manual sort operations are allowed. See, it's not allowing me to sort the table. When I check for error, it is saying in line number 291, you're sorting an internal table, but that internal table is an sorted internal table. Always the data of the sorted internal table based on the key fields will be sorted. So then you cannot sort it again. So that's what system is saying. So let's comment the code, check for error. So here, okay, I have commented and work area declaration. Let me declare and work area underscore maras type. So is there any key field for work area? Who will say, who will answer? Is there any key field for work area? Who will answer? Nobody wants to answer.
I think only we'll declare this memory, I think, using the data key field, right?
Yeah. So if they see work area cannot store multiple record, so there will be no key fields. Okay. So that's what your answer should be. Okay. So let's come back. So now see, now see here. So let me show you the performance also. Maybe it's better if I show you the performance. Okay. Before showing the performance of this sorted internal table, what is performance of binary search and sorted internal table with default sorted? Let's see. Is it better now to show or it's running out of time? Okay, let's
Work area stores a single record, right?
yeah, it stores only single records.
I heard it as multiple.
Internal table stores multiple records. Still you have confusion on that?
No, clear, Raj.
Okay. So let me do one thing. There are 2000 records here, right? I just want to show you the performance. I'll just take some records here in the below. Okay, around I'll just search for this record. Okay. Just copy that record and we'll perform read operation and we'll get the runtime. Okay, we'll get the runtime of the system. So first we'll see standard internal table and then we'll see sorted internal table so that you'll understand the performance of the query. Okay, let's say this is for so this record we want to search, right? So let's search for this record. Binary search is always faster than the linear search. That's what I want to prove here. So let's see, I'll just say get runtime field. So data, I'm using inline declaration, don't worry, we'll see this in future. I'll tell you. Okay, let's say lv underscore start time. Okay, so here after this read statement I say get runtime field data. I want to get the runtime field after reading the record, lv underscore end. So we'll see the new syntax in the future class, don't worry. So I want to get the results of this equal to lv underscore end minus end time minus lv underscore st here at the start time. Okay, so let's write it to output, right to output. Okay, so this one will write it to output, check for error, no errors, activate it. Okay, let's see the performance. Okay, let's see the performance of standard internal table and then we'll see the performance of sorted. I'll just remove all the breakpoints that I had written. So I'll remove all the breakpoints. That's better to remove, otherwise we'll not get the right time the system is taking for running. So let me remove all the breakpoints if there are any. I hope there are no breakpoints. Let's activate the system and activate the program and then execute it. See, around 87 microsecond or something will be there. Okay, that is standard internal table. Okay, so let's enable the sorted internal table. Okay, this is sorted internal table. So I'll comment this code. I'll just copy the same thing. I'll comment this. So now what I do, so I use with table key, because by default if you say table key, by default it will search the record. In binary search it will use binary mode. Okay, so this is sorted internal table. See, I enabled sorted internal table. I commented standard internal table. It was taken 87 microseconds or milliseconds something. So let's execute this. See, 13. That's the difference. That's the difference between binary search and linear search. Clear? So binary search is always faster than linear search because of what? Because of this. See how many times you are accessing for the each record. 1, 2, 3, 4, 5, 6, 7, 8. You are accessing records 8 times here. 1, 2, 3, 4. Only 5 times. If there are many, so here you will access many times. If there are many, so less times here. That's the reason binary search is always faster than the linear search. Okay, if you want to perform, so how can you perform binary search on standard internal table? It's very simple. Just enable the sort statement here and put binary statement here. Okay, binary search. So now it will provide the same. Okay, let me check what is the error. Okay, it's saying sorted internal table, I cannot perform binary search. So here, okay, so by default binary search will be supported, that's why. So lv underscore start. Okay, let me comment this code. It's not required anyhow, so let me comment. Let's see, here also binary search will work. Okay, you can sort explicitly and you can perform binary search on standard internal table. Okay, but everything is explicitly, you have to specify explicitly, but for standard internal table just use table keyword, it will support. Okay, so we'll see 7 seconds, right? So that's what the binary search is all about. Okay, that's what binary search is all about. Don't worry about the code, I'll show you. Don't worry about the code, we'll see that in the future class. So any doubts in binary search and linear search? And these points, key fields are mandatory, rows are always sorted by default. Okay, let me show you the sorted. Okay, we don't perform sort statement, right? Let me show you the sort. Okay, anyhow, let's comment this performance wise. You can check this later if you want to learn performance things and all. Get runtime, it will give the current runtime minus current runtime minus old runtime. That's big. Okay, so it's check for error. Okay, check for error, activate the program. Okay, see now I said the rows are always sorted. Here you can see rows are always sorted by the key field in ascending order. Okay, in ascending order. For this is a key field. Okay, this is a key field. See now when I execute the program, you can see here rows are always sorted ascending order. It will be always sorted in ascending order. See, 86, 97, 98, 7, 617. So it is 598, 619, 620. This is what happening in sorted internal table. Okay, rows are always sorted implicitly. Okay, rows are always sorted implicitly. Okay, based on the key fields. That's what happens in sorted internal table. But in standard internal table, what happens? It will not sorted. You have to manually sort the records by using sort statement. By using sort statement, what you have to do, you have to manually perform sort operation. That's what you have to do for standard internal table. You cannot perform sort statement for sorted internal table, but here for standard internal table you have to do it. If you want in sorted order, you have to do. Okay, see now I double click here. So if you just see the records inside this table, those are not sorted. Okay, there is no sorting here. Okay, see, it's not sorted. See, after executing this sort statement, I press F5. Okay, I came out of the program. Let me enable this breakpoint because there are no executable lines, so it came out of the program. Let me execute one more time to showcase. Okay, see now it underscore Mara. So you can see here the rows are always sorted in. It's not sorted. Now you have to sort it. I pressed F5. Now it is sorted. Okay, now it is sorted. You have to perform explicitly sort statement on standard internal table, but on sorted internal table by default it will be sorted on key fields. Okay, so any doubts?
Raj, can you tell me like what is an implicit and explicit?
Implicit means, see, implicit means by default it is there. Okay, explicit means, see, you have to put something like this sort statement.
Means some conditions you have to put, is
No
it?
condition. See,
Explicit.
this is sort operation you are performing, right? On the internal table, you are saying sort it underscore Mara by MATNR. You are saying, right? This is explicit.
Yes.
So for sorted internal table, did we say something like that? It was not at all like allowing us to sort, right? So still the records were
Yes.
sorted internally, right?
Okay.
That is implicit. This is explicit. Clear?
Yes.
Okay, so let's move further. So sorted, I also told it supports non-unique key field. Okay, let's see non-unique key field. Okay, let's uncomment this key field. See here, you can put non-unique. It supports both unique and non-unique key. So here you have to be very much careful. If you're saying that MATNR is a unique, if the record must and should be unique. Okay, the records of the internal table based on this field must and should be unique, otherwise this will provide dump. Okay, otherwise it will provide dump. Okay, let's say what I will do, I'll say to system that mtart is a unique. Okay, mtart is a unique. Okay, I say mtart is a unique. So what it will happen, we'll see in the runtime now. Okay, it will give me a dump if I say like that. Okay, because I'm saying mtrt is a key field. See here, a row already exists with this key. It's giving and dump. You should be very much careful when you're using sorted internal table while specifying key fields or non-key field. Okay, you should know whether the based on that field the data is a key record, the data is a unique or non-unique. Okay, you should be very much careful while specifying the key field. Okay, now if we say non-unique, will it provide dump? If I say non-unique now, will it provide dump or it will not provide dump? It won't provide dump because I'm saying that based on this key field mtrt, the data is anyhow non-unique. Okay, it is a non-unique data, so store it like non-unique in itself. Also, what will happen based on mtrt, the records will be sorted. Okay, see now I press F5, it is not providing the dump. See, based on mtrt, records are sorted. You can see the records are sorted based on the key fields. The key field is mtart. Okay, sorted key field. See, mtart. That's what unique key and non-unique key. Understood when you have to go for unique and when you have to go for non-unique, when you have to say specify unique key field and when you have to specify non-unique key field. So when the records are unique based on the material, based on the field or a column, you can specify it as a unique. Okay, if records are not unique, so based on the key columns, based on the columns, you can say non-unique. Okay, non-unique. Still the based on non-unique, it will be sorted. Clear? Any doubts up to now?
Raj, how do we know whether a record is there unique or non-unique? Because we are writing.
Yeah, very simple. Very simple. Let's just go to tables. Let's say you're bringing data from Mara table. Okay. So this is answer for your question. So Solman, see here. So in table itself, you can see key field or non-key field. If you go to MARC, if you're bringing data from MARC, if it is a non-key field, then definitely it will store the duplicate index. If it is a key field, then it will not store the duplicate index. If there are two fields here, see, you have to specify. If you say unique, then you have to specify both the key fields, material and WRKS here. Okay, if you are writing based on MARC, then you have to say MATNR or WRKS is unique. Okay, unique here, sorry. If it is a MARC table, okay. If any other table, you can check on the table and then you can decide whether the data is unique or not. Clear?
Yes, because no, the data table wise I know, but I wanted to check whether when we write a program, suppose we don't know the table, we're writing some logic. So at the time I'm just asking how do we find? So we every time we need to go to table and check, no?
Yes, whenever you're declaring sorted internal table. So means
Okay.
if you're creating an internal table, So there should be, you will be writing select query, right? On the mar, or else
Yeah.
if you are trying to append some records in you cannot perform append actually. If you are trying to perform some append or inserting some record from other internal table to this internal table, you have to make sure that it's a key field or non-key field, means entry is unique or non-unique. So if you more confused, if you have more confusions on key field and non-key field, just go for non-key. Okay, it won't impact much. Just go for non-key field, non-unique. Okay. Okay, so this is all about sorted internal table. Okay, let's come to the next one, hashed internal table. Okay, hashed internal table. Let's see what is hashed internal table now. So it supports no row index. Okay, it support no row index. Okay, you cannot perform index operations like index 1, index 2, or index 3, delete where index equal to 1, read where index equal to 2, or modify where index equal to 3. This kind of index operations or will not be performed. Okay, you cannot perform index operation on hashed internal table. Okay, hashed internal table. Okay, you cannot perform index table on hashed internal table. So here, this one standard internal table supports non-unique key. This one supports unique and non-unique key both, but hashed internal table supports only unique key. Okay, hashed internal table supports only unique key. Okay, it won't support non-unique key. Okay, hashed internal table supports only unique key. So next point, here also key field, specifying key field is mandatory. Specifying key field is mandatory. Specifying key field is mandatory. Here also specifying key field is mandatory. Okay, next point. Okay, so here we use a linear search. We can also perform binary search on standard internal table. Explicitly we can perform, okay, by specifying binary search. Here it's support by default binary search. We can use table keyword, so by default it will read using binary search. So here there is no linear search and there is no line binary search. It uses hash algorithm to search. Okay, it uses hash algorithm. Okay, hash functions. Okay, okay, it uses hash functions. It uses hash functions based on the key field. Okay, based on the key field. It won't support linear or binary search. Okay, it uses hash functions based on the key field. This is one more new feature for hashed internal table. So here lookup time. Okay, here lookup time always proportional to number of records in the internal table. Okay, so always proportional means we cannot say how much time it can take here. That's what it means to say. Here lookup time is same point here also, here also lookup time is constant. Okay, lookup time is not constant, it always proportional. I have written proportional. Okay, proportional. Okay, it is also proportional to number of records in the internal table, but here lookup time is always constant. Always constant. Okay, lookup time is always constant here. Let me get it. Lookup time is always constant. Always lookup time is always constant in hashed internal table. Okay, so or else approximately same. Let's say approximately.
So we get any interview questions out of this internal and work
Yes,
area?
definitely you will get. That's why I'm preparing this many things. Definitely you will get. Approximately Same. If you answer each of these points, remember, no one will reject you. No one will reject you if you keep answering these things. I am all this PPT I'm preparing for interview purpose only. No one will reject you. Approximately same. Okay. So approximately same. Okay. Lookup time here. Okay. So here, and one more point that you have to remember is you can perform rows can be sorted. Let's say rows are always not sorted. Okay. Rows can be sorted explicitly. Okay, you can perform sort statement on this explicitly. You can write sort statement explicitly. You can perform sort on Hasht internal table. Okay, Hasht internal table. Approximately. What is spelling for approximately? So this is a problem.
It's MATL.
This is spelling, right?
So MATL.
Okay. Okay, here row can be, lookup time is always constant, and row can be sorted explicitly. Okay, let's see how can we see this. Hey, so let's go back to our program that we are creating, so that we are using to understand this basic programming again. So I lost the connection. So let's declare. Okay, you cannot create non-unique keys here. It only support unique keys. Key field also mandatory for sorted internal table. Okay, so let's say here, see here, hashed internal table. Okay, so let's say data. Okay, so it underscore mara. Okay, type hashed table of mara underscore ty with unique key, let's say manner, with unique key matnr. Okay, so let's declare work area underscore mara type structure mara underscore ty. This is a syntax to create. You have to use hashed table. There's not much difference here. See, standard, sorted, hashed. That's the difference. And also difference is this one. You have to remember this difference. Why you have to remember? Because of interview question, or whenever you remember this kind of concept, you will write a better programming. Okay, you'll write the performance programming. When you have to go for Hasht internal table, when there's a large number of records, okay, when there are large number of records and you are performing more read operation on a particular specific field, so this gives better performance compared to any other internal table. Then in that case, you can go for Hasht internal table. Let's say read table. Okay, we'll see this after this. Okay, we'll continue step by step. So let's say read table it underscore mara, so into work area underscore mara, let's say index 10. So can I perform this? Let's see. Check for error. See, you'll receive an error. You cannot explicitly or implicitly index operations or on this table is not allowed. Okay, you cannot perform this index operation on Hasht internal table. It's not possible. That's what I was saying. No row index. Okay, you cannot perform index operation. You cannot access the records. You cannot access the records using this index. Okay, you can only access the record using key fields. Okay, so let me reduce this little bit. I have to write a few more points I missed, I think. So here you can access records using key fields, or using key fields only. Hey, you can access records using key field only. Okay, let's say here so here with key, matnr. See, I'll use this record. So here, okay, so let's see this record. Lookup time, I said always constant. Okay, approximately same. Constants means approximately same, I mean to say. Okay, because sometimes theory things won't work out in practical, so I have to change the statements after seeing the practical things. That's why I made approximate. Okay, let's see. Always constant, approximately constant. Okay, we'll see the results for this. So let's do pretty printer, check for error. Let's use check for error and activate it. Okay, it uses hash functions, hash algorithm to search the record. Let's remove these breakpoints and all, and we'll just execute and we'll see the time. Okay, this is around somewhere around I think 1600 records near to. So activate the program. So I have to write the result to output, right? So just activate the program and then again once again execute it. See, 8 seconds. It's faster, very much faster compared to any record you search. Almost you'll receive the same time, but here depends on the number of records that you are searching. Let me show you that. Here let's say we'll do one thing. I just want to do one thing here. I'll just take any of the record. Let me comment this. I just want to show you the difference. Approximately same I said, right? I just want to show you the difference. So let me remove this binary search also. Showing some LV underscore results is unknown. So okay, I have to enable this also. Please go back and practice these things. Practice is very much important. How much I will teach you, how much I do, until unless you practice and you do the experiments, you will not learn. Practice is very much mandatory. Okay, let's see for the sorted intent table. I'm searching this record. Okay, so let's take one more record. Okay, let's take 2 record example. First I just want to take it in a debugger mode and then we'll look for other record. Okay, I said lookup time is always constant, right? So let me check. Let's take few records from here. I'll just take this one. Okay, let's search. I'll just keep it in notepad so that it will help me to use in future. Okay, some record here and maybe let's take one more record in the below. Okay, I'll say this record. Okay, we'll search records this to time and we'll see the time of the standard internal table and then we'll see hashed internal table. Then you will understand. See the time of linear search. Okay, so let's access one more, the last record of this one. Let's see again here. That's how linear searches work. So if you sort, maybe it might depends on the records again. Because of the debugging, it has taken more time. Don't worry. So I'm removing the debugger now. So first one more time we'll search for this record. Okay, it is there somewhere in the starting. Okay, activate the program and see the performance now. Performance of this one now. Execute around 18 seconds, right? So now what we do, we'll copy the last near to last record and we'll read that record. Okay, so activate it and then execute it. So it's taking around near to 1 second. It's not near to 1 second. I think 1500 or something millisecond or microsecond it will be there. See the time, it's around more than 1000, right? So this is how standard internal table will work. Okay, lookup time is always constant, always proportional to number of records in the internal table, the records that you're searching. But in hashed internal table, it's not constant, it always constant. Okay, to approximately it is same. Okay, let's search for this record first and then we'll see. Okay, let me search for this record first. It's near to at the starting position. We'll search for this record and we'll see the time that has taken from the sort hashed internal table. And then what we do, we'll search for the last record. You have seen, right? There was very big difference in the standard internal table because of the lookup time for the record. So execute it. So it's around 14 seconds. Okay, so let's copy the last record. So here also just do printer and activate it and then execute again. See, 14 seconds. Lookup time is always constant. Okay, here lookup time is always constant in the Hasht internal table. That's what I mean to say. So whatever the record you're searching, you're searching for the first record or for the 1000 record, the lookup time is always same. Okay, in the Hasht internal table. Okay, so you can perform row sort explicitly. You can perform sort statement. You can perform sort it underscore Mara by Matner. Okay, you can perform this sort statement explicitly. MATNR, check for error. Okay, activate it. See, it's allowing you to sort records explicitly. You can execute 12 seconds. It is set. It's taking after sort for the last record. Let's search for the first somewhere here. Let's search for the first record of the internal table. Let me check in the debugger what is the first record. So this is near to last record, and we'll take the first record and we'll see the timings. I said constant, right? So let's see. Let's take the first record or second, third or fourth record. Okay, let's take this record and let's search it and we'll see the timing. Okay, so we'll see the time. I'm in the debugger, don't worry about the time. Okay, I'll remove the breakpoint and I'll search for that record here. Let's do pretty printer now. So it was taking around 12 seconds after sorting to search the last near to last record. Now we'll search for this one. See the time? Approximately time, same 10 seconds. Let's execute one more time. 10. One more time. It's taking time. Okay, approximately same, approximately constant it will provide. Let's search for this record now. Let me copy this also to the notepad. Okay, let's search for this record. Do pretty printer again, check for error and activate it. And execute it now. Execute it. See, 8 seconds. 8 seconds. 9 seconds. Approximately constant always. Okay, approximately constant. Okay, it's not like this binary search or linear search. Okay, in binary search and linear search it always depends on the records that we are searching, but here it's approximately constant. It supports unique key field only. Okay, everything you understood. Any doubts up to now? Any doubts?
Raj, any clear?
Yeah.
Yeah, someone, you go ahead.
Go ahead, no problem.
No issues.
Since Hasht internal table is much faster compared to sorted and standard, but why we are not using in real time?
Very nice question. It's a very nice question. So what it supports only unique key, right?
Yeah.
So what if you have non-unique key fields, non-unique data? What you will do that time?
Okay. So that's the reason they're not using, right?
There are many reasons, and also Hasht internal table will take more space compared to other internal table because of what it will do. It will again store this key field is there, right? What are the key fields that we provide? The key field. So it will create one more memory, and it will create this it will change this field into hash values. Hash values will look like something like this. Let me show you how they will look like. Hash values. So let's see, let's say US table. Okay, so this is how hash values will almost look like. Okay, like this. Oh, not this one, it is binary value. USR 01. Let me check. Somewhere in the table it will be there. Hash values. It will convert the values into hash and then it will search. Why I'm not getting? Okay. USR 20, USR 02. Let's see, 02 password table it will be. I'm just looking for the password table. Okay, let me search here. See, it looks almost like this, hash values. Okay, what it will do, it will convert the key fields into hash values and then it will search. So why can't we use? Because it always supports unique key. So it's make little bit difficult for us to use. And also thing is, if you are performing more read operations on the internal table and the table size is very large and the performance we need more performance, then we use. Okay, why we don't see in the program or the functions? Because of lack of knowledge. People don't know when we have to go. Not everybody, few of them. Okay, if they don't know when we have to go, if they don't remember these concepts, then it will become difficult for them to decide which internal table they have to go to. That's why I don't
Okay,
see.
okay,
Okay, so if you have
okay,
knowledge, you can use it. If you don't have knowledge, if you don't have conceptual knowledge, it makes difficult for you to decide for which table you have to go through. Now you have the proper knowledge, you can decide, right? Now you got the capability to decide which internal table you have to use at what time, when you have to go for binary search, when you have to go for linear search, when you have to go for this Hasht internal table. You understood or not today?
yes, yes,
So
yes.
if you remember this concept, it will help you to
Yeah.
decide which internal table when. Okay.
Okay, okay,
So if you
okay.
don't have knowledge, if you don't know what is Hasht internal table, then what you will do? Will you use? No,
No,
you leave it, right?
this is,
So that's a thing
yeah.
you don't see. I use always. I decide based on the internal table records that I'll be bringing. If I'm
Okay,
performing
okay,
more read operation on the same internal table, then definitely I'll use Hasht internal table, and I will also think whether the key is unique or non-unique entries also. Okay, I'll take all these things into picture and then I'll decide while writing the program. That's how I do. I don't know about others. I cannot judge about others, but that's how I do actually.
okay,
Most of the times you'll be seeing the standard internal table only, but I don't do the like that. I decide based on this concept. Clear?
mm. Yeah, yeah, that's very clear.
Okay. So any other doubts?
You know. Go ahead, Deepak, go ahead. So, sorry.
No, no issues.
Yes.
So in this case, like Raj, most of the times, like maximum cases, like standard table only will be used, right? In most of the
Yeah.
programs.
Why we use standard table? Because we don't know when we have to go for it. Maximum time you see program, maximum time you'll see standard tables.
Yeah, yeah.
Because lack of knowledge.
Okay.
But that's not the good way to do. We have to decide based on deciding this, based on keeping this concept in our mind. We have to decide. Clear? Any other doubts in
Yeah.
today's
Yes.
class?
Raj, but the advantage is in the standard table, as you said, we can sort it in explicitly, right?
Yeah, we can do anything. Here also, as internal table also you can sort. So see, sometimes what will happen, you may have to sort internal table multiple times, right? So then you cannot use
Yeah.
this sorted internal table. That's a disadvantage with sorted internal table. But in standard internal table, you can sort however you want. But sorted internal table will not allow you to sort tables internal multiple times. In that case, you cannot use sorted internal table. Then you have to use standard internal table. Clear?
Okay.
Okay. So any other doubts?